Let's start from here because we already waited 3-4 minutes. Hello, everybody. My name is Peiman. I am an IN4ACT researcher residing in Luxembourg from Luxembourg Institute of Science and Technology. Today, we have Mr. Alessandro Stefanini to present a topic regarding the very hot topic. Actually, it is the title is "You Can't Manage What You Don't Measure." It is regarding the social physics and Industry 4.0 for investigating human factors inside business organizations. This webinar is one of the series of IN4ACT Webinar series that we are holding in here to have more contribution to the research activities in Kaunas University and to introducing our researchers in IN4ACT team to have more interaction with the university and with IN4ACT projects. So I want to just introduce Dr. Alessandro Stefanini as our presenter, who is a management engineer. He's a researcher in the IN4ACT team at the Kaunas University of Technology, and he's also a researcher at the University of Pisa in Italy. His main fields of research are business process management, process mining, healthcare management, operations management, Industry 4.0, and circular economy. He obtained his PhD in enterprise engineering at the University of Rome, Tor Vergata. And Alessandro's working experience are like multinational corporations that MIT is one of them on production planning and process engineering. Tomorrow, actually next week, we will have another presentation in this webinar series that our researcher, Dr. Manuel Morales, will present, and I invite all of you for that presentation as well. Thank you very much. During the presentation, you can simply turn off your cameras. You can ask questions via chat. You can actually raise your hand and ask questions, or you can just join us with keeping your cameras on. And at the end, we will have 10 or 15 minutes for questions regarding this webinar. So thank you very much. Alessandro, please go ahead.
Yes, good afternoon to everyone. Thank you very much, Peiman, for the very kind and long presentation of myself. I don't think I have to add anything. And thank you again. Thank you for joining to this webinar. And as said by Peiman, we start to see the base concept of social physics and how this concept and the new technologies can help us for understanding the human factors inside the business organizations.
Okay.
Let's go to the index of this presentation. We will start with very few words about the history of social physics and its definition. Then we go further with some application examples cited by Alex Penton, that is the inventor of social physics. Then we move further for understanding the role of new technologies in this subject. And then we go in deep in understanding how social physics can help for studying business organizations. And I will present some case study that I carried out with my colleague from the University of Pisa and from the MIT. So just a few words about the history before social physics. Well, it's very important to understand that, as said by Aristotle and many other philosophers and scientists, humans are social animals, and most of their activities are carried out in group. So it's very, very important to considering these social dynamics that are behind economy, behind political revolutions, behind the behavior of organizations. And this is the background from we want to start, okay, for introducing social physics. So these social dynamics are really important for all the activities of human. Since 19th centuries, Auguste Comte introduced a new discipline, that is sociology, that take care about these aspects underlying society. He proposed a new scientific method for studying social life, social change, and the social causes and consequences of human behaviors. This is the base of social physics, at least the base for the social part of the word social physics. Since the 19th centuries, the world has changed for sure, and just recently, a very important and preeminent scientist of the MIT, Alex Pentland, proposed this new term, this new field of research and discipline, that is social physics. It mainly consists in a social science that tries to describe mathematically the connection between the information, the idea flow, and the people behaviors. This is done in order to understand how such behavior, such information exchange and idea flows can affect the productivity and the norms that underline our companies, our cities, and in general, our societies. The difference between social physics and the sociology behind social physics is that usually with sociology, you try to abstract models of human behavior more theoretically, and then try to do some very large study without a direct measurement of human behavior. While, thanks to the new technologies that we have today, Alexander Pentland proposed to apply mathematical model for studying social movement in living labs. It means like analyzing real and direct measurement of many characteristics of human behavior. Why he called physics after social? Social, okay, we understand that derived from the from sociology. Why he proposed physics? Because physics usually, at least the classical physics, not the quantum one, try to understand how the flow of energy translates into change in motion. Pentland proposed social physics in order to understand how the flow of information and the flow of idea translate in change in human behavior, and how this can affect our society, cities, business organization, etc., each group that we can identify. Social physics usually analyze pattern of human behavior, information exchanges, verbal and non-verbal, and this so-called honest signal, that is also another concept invented by Pentland. With this honest signal, he meant to involve the honest signal that we release while we are talking, for example, the face expression, the eye contact, and so other behavior that are unconscious for us, but that we can see as another part of the behavior, okay? Not the conscious one, but the unconscious one. And as said by many scientists, this is a very important part of our communication. So is this the different? I mean, staying remotely is different from staying together, because through the camera we lose some part of this communication, for example. Social physics permit to investigate and modeling human behavior during the real human activities. And then in the following slides, we see how we can do that. And then it permits also to assess the effect that human behavior can have on many different elements of our society. And with this presentation, we will focus in particular on the business organization. Many different behavior can be studied with social physics concept, and we will see some example. For example, it is possible to study the behavior of creative groups, like, for example, a product development teams. And this is an example reported by Peiman in his book, Social Physics, where he tried to study the communication patterns product development teams, and to understand which kind of communication patterns are more productive than the other. So he studied really the communication patterns during this team, okay, with some special tool that we will see, and to understand which type of pattern are more productive as final results, more ideas, better ideas, etc. in this case. It is also possible to study the evolution of these interactions between teams, for example. Okay, so we can follow, for example, the interaction during 7 consecutive days of these creative groups. But it's possible also not just to observe the verbal communication, but also it is possible to study, for example, the email datasets. For example, in this example, they studied the email of faculty members, to understand which faculty members communicate more and less inside the faculty network. And this way you can understand, and in case also intervene to improve the pattern behind these email networks. For example, on the right, we can see the situation before and after an intervention on a network of a business organization. But it's possible to extend this concept also to the cities, for example. For example, collecting the data of the GPS, for example, collected by Strava or other application for running, you can understand where people go running. And designer of our cities and municipality, etc., can intervene, for example, to make safer the space where people tend more to run, for example. Also in this case, you can exploit GPS data and understand how people is acting. Or it's possible to study other aspects of our city, for example, the traffic, as Google Maps in some sense do it, or the crime areas, or for example, the behavior of people in some area, for example, understanding where people are more affected by some particular illness and their lifestyle, for example. But it's possible also to study the individual behavior. For example, Peiman in his book tried to study the behavior of a person based on his credit card transactions. Okay, so where is spending his money, and you can understand his typical behavior during his life, for example. But since it is very important to study sociology and the social part of human behavior, why is just born recently this idea of social physics? It is born just recently because in the past it wasn't so simple to collect direct data about our behaviors. But today we have at least 2 types of data that we can exploit. One group of data is related to the data that we all days we put on internet, or anyway in some kind of networks, and could be the social data, the email that we exchange through business network or through internet in our private life, our credit card, our GPS data, etc. That we can call also in some way big data. And then another group of data that is related to new technology, to new physical technology, in particular the new IoT tools that can permit to measure different aspects of our behavior, such as, for example, our speaking, our movement, etc. And usually this group of data were analyzed with statistical techniques, the standard one like regression, correlation, etc., or applying more complex techniques like, for example, the machine learning algorithms or the social network techniques. Anyway, is this the reason why it is a recent discipline in social physics? Because we hadn't so much data about people, about behavior of people before the last years. For example, just to have an idea of what kind of data we are talking about, we can, for example, analyze the business email of a specific project teams to understand how they interact internally and externally from the team. We can, for example, analyze the log of activities and the documents history to understand who is working with in an enterprise. Or it is possible to exploit the Facebook data. Now is more harder. In the past, it was simpler due to the Cambridge Analytica problem, I mean. But anyways, it is possible to exploit the Facebook data to understand the network of people. And then the other side of the technology that is related to the IoT and wearable tools. For example, the sociometric one, that is this kind of tool, the sociometric badge, was invented by Pentland and is invented for studying social physics. So this tool is fitted for social physics because it was invented for it. And it was invented at MIT Media Lab. This tool has 4 sensors, for example, an accelerometer, microphones, Bluetooth, and IRDA. And it can permit an automatic and direct measurement of individual and collective behaviors, so the individual one and also the group one. And it can measure mainly the body and posture movement, the speaking activity, not just the speech, but also the tone of the voice, who is interrupting who, and etc. It can understand the noise in the place. It can measure the interaction and proximity networks of people involved. It can also measure the mirroring between wearers. The mirroring is based on the mirrors theory, mirror neurons theory, and it measures in particular how we start to act in a similar way while we stay together. Because there is a theory that if we stay together, step by step, usually we start to act in a similar way. For example, if I start louding, probably also the other people start to have a higher volume of the speech, for example. And then it also guarantees the privacy because Alessandro Stefanini is very sensible on this point, because it doesn't record the content of the speech because it's sampling. By sampling the signals, it is impossible to rebuild the content of the conversation. But there are also many other tools now that you can exploit for this kind of studies that are smartwatch, smartphone, some environmental sensor, heart rate clock, etc. These kind of tools are not intended for social physics, but we can exploit them also for social physics. What are the differences between the methods followed by traditional social science studies and these social physics studies? The main difference, as underlined by the book of Pentland, is the number and pervasiveness of behavioral measurements that we can do with the this new kind of tool and the concept of social physics. In addition, also the reliability of the measurement is higher. Anyway, social physics try to seek the richest quantitative descriptions possible. So it is a quantitative discipline. In fact, with traditional social science method, usually we try to measure the human behavior with interviews, questionnaires, direct observation, and reports. But unfortunately, these kind of methods are affected by some bias, for example, the subjectivity bias, the memory bias, etc. And they present some very important limits. While the social physics methods try directly to measure the behaviors. I mean, with a survey, for example, I ask people after a team session, ask their behavior during this session. For example, asking how many times, for how long you talk and during during the team meeting, how you perceive the other during the meeting, how many times a person interrupts you while you're speaking. On the other hand, with these tools and these methods, it is possible to directly and quantitatively assess when, why, and not why, no, when and how many times, for example, a person interrupts you while you're speaking, or for how long you spoke. Okay, so we have a more objective results, a greater number of behavioral variables can be collected with this kind of tool. For example, your body movement, your posture, that is quite impossible to collect with a survey. And so we have a bigger amount of data and also collected in real time. So you don't suffer of memory effect. For example, if I have a very long meeting of 3 hours, it's quite impossible to remember at the end of it all the behaviors that I have during the team meeting, okay? In this way, you are collecting the data in real time. This is valid for wearable sensor, but it's also valid for your emails, for example. Also the emails that are different information exchanges, but also in this case, you can collect the real content of your emails, the timing of your emails, and assess and make some analysis on them. But now we are trying to focusing how social physics can help in business organization, why it's important, and we will present also some case studies. In particular, business organization, since many years ago, try to control their process and to assess their performance. For example, they use sales dashboards or the machine KPIs that you have available at the production lines to understand how the machine and tool and instruments are working, which is the efficiency, etc. So in the year, they developed very sophisticated tools for assessing these aspects of business organization. But unfortunately, one crucial element tends to be overlooked by organization, and this is the people. But unfortunately, organizations are made, or likely, organizations are made of people, and neglecting them while you are studying organization is a very big limit. This is particularly true, for example, for service organizations, where 90% of activity are carried out by humans. But it is valid also for many functions inside manufacturing companies. Also, if now the production is going to be more automatic, many other aspects of business organization remain in the hands of humans, and therefore the human behavior highly influence the performance of such process. So the human behavior, the human interaction, as individual and as groups, highly influence the final performance of business organization. So step by step, organizations are trying to control also these aspects because they understand that is important for their results. And social physics so changes this situation. Okay, it made possible this kind of analysis and improving the performance also thanks to an improvement in the behavior of individual or teams. In fact, social physics permit to study employee behavior, employee attitudes, and to understand if some kind of interventions are helpful or not. So to evaluate the potential positive effect of an intervention on business performances. For example, the Peiman groups of research investigated a call center, the call center of Bank of America. And for example, he found out that you can obtain an increase in productivity if the employee take breaks, if the employee of the same teams take breaks together with colleagues, and if they interact during such breaks. Because before, Bank of America, for example, tend to divide the break time between colleagues just because they want to avoid they lose time because they said, okay, if they stay together, they tend to occupy 5 minutes more for the breaks. But thanks to these sociometric studies carried out with the sociometric badge, Peiman discovered that it was false. It is better to stay probably also 5 minutes more together during the breaks, but to stay together and interact. Probably because people tend to share their vision, their idea, and also solving problems. And so they are more productive. Another example, also this from the group of Peiman. They studied some kind of workshop at MIT. And during this study with the sociometric badge, they also provide some feedbacks to the participant of this small group meeting, trying to fixing the problem of the communication. So trying to move from an asymmetric communication patterns to a more symmetric one. And they discovered that thanks to this feedback, the results of this group tend to increase. Now we can go in deeper with 3 real case studies that I carried out with the colleague of the University of Pisa and colleague from MIT to understand how we can really apply social physics concepts in business organization and how we did it in these 3 different case studies. The first one is related to the breast surgery. And this study, we aimed to investigate the team coordination dynamics during breast surgery and their relationship with the occurrence of surgical glitch, namely procedural and medical problems that we can have during a breast surgery. I have to underline that this procedural and medical problem, we are intending also the small one, okay? We are not looking for the death of the patients during these studies, okay? the sociometric badge for studying the team coordination dynamics in this case. And the major research aim of these studies is related to test a hypothesis that we did before the studies, and starting from the background behind the routine tasks, coordination, and behind the surgery. And the hypothesis was the lower the proportion of explicit coordination of surgical team by verbal interaction we have, the higher is the performance of the team, as we had less surgical glitch during the surgery. This is the standard methodology that we follow with this sociometric study, but it is a standard methodology that we use typically if you want to make a behavioral study with the sociometric badge. Usually you have a phase of research setup where you have to understand the context where you apply the sociometric badge. You have to fix some case study parameters, and in particular you have also to test the tools, and you fix the parameters of the tool to understand, for example, for one parameter that you have to fix, for example, is which is the distance of proximity for your case. For example, I can, for example, consider that I'm in proximity with my colleague if I am in the 2 meters radius or in 10 meters radius. It depends from the specific context, and you can fix this parameter. Other parameter that you can fix is related to the volume of the voice, for example. If it's a noisy environment, you have to change the parameter of the sociometric badge, for example. Then you have a second phase of data collection, where you collect the data with the sociometric badge, but also with other instruments, because usually you want to correlate and make a relationship between the behaviors and something else, for example, a performance. In that case, we collected the data about the team cohesion, and we collected the data about surgical glitch because it was our performance. Then we have a phase of data analysis, where we can use, as in this case, standard methods like correlation and regression analysis, or we can use some more sophisticated type of analysis like machine learning one, etc. This particular case study, we collected the data of 82 breast surgeries with cancer-related problems. And the surgical team that we studied was composed by a minimum of 4 persons to a maximum of 17 members. And we collected all of the data related to the behavior with the sociometric badge. In fact, our independent variable in this study are the team behaviors, like body movement, posture movement, speaking activity, the audio, the proximity, the interaction networks, and the mirroring. More or less are these the main class of variables. And we also collected the team cohesion through an appropriate survey to understand if people has already collaborated with team members before the surgery. So before the surgery, we asked them how they feel about the team members of the specific surgery, just to understand that if there is also an influence of the past in the current surgery. Then we also collected some control variable for controlling our statistical models, and the dependent variable, as said, it was the surgical glitch occurred during the operations. In particular, we treated this variable as binary, so the presence or the absence of medical procedural problem during a surgery. And just to make clear which variable were relevant to this study, in this study where we found that the most relevant variable are the speech one and the mirroring one, and also the team cohesion as some X in our statistical model, so in our study. As the analysis, we did the correlation analysis, where we found some interesting correlations. Then we applied the logistic regression, exploiting 3 independent variables. We applied the logistic regression and not the linear one because we had a dependent variable that was a binary variable. So we applied the logistic one, but anyway, it's more or less similar to the linear one. And we didn't have problem with the control variable. We tried to understand if the control variable has an influx on our results, but we didn't have a problem. And then we have a phase of interpretation with the physicians and the health managers to understand how to interpret the data, because the interpretation of the data remains human, remains researcher driven. Likely, otherwise we can also stop to do research and just apply tools without scientists. As key findings that we can understand from this study that we have seen very quickly, just to understand how social physics can help in this real context, we confirmed that team behaviors and team attitude has an important influence on the final results, in this case evaluated with the presence or absence of surgical problems. And in particular, we can confirm the hypothesis that we posed, because we have that a lower explicit coordination and a higher implicit coordination measured with the mirroring have a positive effect on the outcome, namely a negative effect on the presence of surgical problem glitches. Okay. And then also the team cohesion, we discovered also, we confirmed as in the past study that also team cohesion has a positive effect on the surgical outcome. From these studies, from these results, thanks also to the contribution of health managers, we can understand, we can devise also some practical implications. Just to make an example, for example, it is important to understand, it is important to underline that a well-defined task distribution before the surgery is really important to avoid the discussion that it can burn during the surgery, and that can drive to have more glitches, as shown by our data collected with the sociometric badge. This is probably related to a distraction effect, because if I'm discussing very hardly, I mean, with colleagues, or anyway, if I'm discussing of the surgery topics, but also of other topics that could be football or something like that, it's more likely to have a problem during such surgery. The second study,
you have less than 5 minutes.
Yes. In fact, the second study I already thought to be very quick. In this case, because this is very, very similar to the previous one, the only difference here is that we studied the emergency department teams and not the surgical teams. And in this case, our interest was to understand how the surgical team behavior can affect the patient satisfaction for the emergency department service. Also, in this case, we used the sociometric badge, and so the methodology was the same. It just we have just difference in the object of our studies. So I think we can skip these studies because, I mean, it's very similar to the first one. Anyway, just to have an idea, we collected, for example, 575 hours of work thanks to these tools. Also here we use the same independent-dependent variable, so I skip for this reason why. And we go to the third study that we carried out, that it was different from the previous one, because in this case, we didn't exploit the sociometric badge, and the context is completely different because the first two contests were at care one, while here it is heuristic hubs. In this case, we tried to empirically explore how human and also environmental factors can affect the performance of warehouse workers during their activities. In this case, we exploited the smartwatches, smartphones, and some special smart environmental sensors for assessing temperature, humidity, etc. The study was carried out in a semi-automated logistic hub of tissue products in Italy. This is the scheme of the data collection, where we have some smart environmental sensor for assessing, for example, humidity, temperature, luminosity, etc. We have also smartwatches that the workers wear during their common activity. These smartwatches communicate with smartphones and with a special app developed by the MIT Center for Collective Intelligence. And thanks to this system, we collected the environmental and behavioral factors of workers, like also in this case, their body movement, their speech activity, etc. In this case, also their heart rate, etc. And then we try to assess their influence on the productivity of workers, that it was simply assessed exploiting the data inside the warehouse management system. As you can see, this research lasts 2 months, and we collected 1,600 hours of worker. These are the list, the class of the measure that we collected. In this case, also the data analysis phase was different because we exploited some special machine learning regression model, namely called CatBoost, where we try to understand the effect of all predictors on the prediction of the hourly production of workers. So to understand which are the main factors that can affect the productivity of workers. In order to show the results, we exploit the Shapley value in order to show with this graph which is the effect of a behavioral variable, for example, the operator's interaction that is on the x-axis of the picture on the left side, and its effect on the y-axis, that is the productivity of workers, that is on the y-axis. The 0 represents the average on both axes, and so we can, for example, understand that the interactions between operators tend to be good during the morning shift, because it seems to very slightly increase the performance, but it seems to be very detrimental during the afternoon shift. As you can see, it reduces the performance during the afternoon, as shown by the color. One, red, it represents the afternoon, and blue, it represents the morning. Here on the right, we can see also the effect of some particular interaction with some particular user. As you can see,
two more minutes.
Yes, I just finished with this graph and the final remarks. For example, we can see also that heart rate, so the state of activation of workers, can affect the outcome of these workers. Think about that workers stay on forklift, so is not affected by, they don't move stuff manually, so they use forklift, so they don't, I mean, otherwise it's normal that I have an inert rate higher if I'm doing something manually, but they use forklift always. And for example, we can see that if they are more active, they tend to produce more. The same we can see with the body movement. So if they are more active, they tend to produce more. Same results we can find with some environmental variable. For example, the luminosity. We can see that we have, in particular, below some special value, we have a very big effect on productivity, and in particular on some, not on all individual, or better, it is, this effect is on all activity, on all workers, but some workers are more affected by these variables, as you can see from the red color in the graph. So also in this case, thanks to this social physics concept and the application of these tools, it is possible to confirm that human environmental factors affect the performance of warehouse workers. There are some more specific results, like for example, the level of activation is important. The interaction between workers and with the supervisor, and also some environmental conditions like luminosity and temperature. So, for concluding with some remarks, also thanks to our case study, and in particular thanks to the case study of Alex Pentland, it is possible to show that social physics concept and tools can really support the investigation of human factors in the business organization, and they can help to improve such behaviors, such interactions between workers, between employees, in order to improve the final results of these business organizations. And it will be more and more true thanks to the new introduction and other data present in the big data paradigm, like, for example, the emails, etc., the social network interaction, and so on. And this is a reality, and it is not just on paper, because as shown by our case study and by the case study of Alex Pentland, it is really possible to apply this concept in the business organizations.
Yeah, Alessandro, maybe you can consider, yeah, you are finishing, I think.
Yeah. No, I finished as, I mean, okay. That was the final remarks. I just want to, this is just an appendix, I mean, just to show and to share with the
it is very important
KTU faculty. Yeah. Yes, what I'm working on, and just to try to involve somebody on my research topics. And the first one is particularly related to this social physics concept, so is also in topic with the presentation, because I'm analyzing multidisciplinary meetings of the breast unit at an Italian university hospital, the same of the case study previously presented. And I'm working on it. We have already collected the data with a colleague of the MIT and one colleague from the University of Pisa. But we are trying to assessing the results, and also to put the background of this research. So there is the possibility to involve one or two KTU faculties with a management research background for finalizing and refining this research. So we are open for this collaboration. Then it is also possible to apply this concept, in particular with the smartwatch, because my colleague at MIT now is switched to use more the smartwatch than the sociometric badge. And so we can replicate or do different studies using the social physics concept and the smartwatches, smartphone, etc. Also in a Lithuanian context. I have to say that it's quite time-consuming, this kind of work, but they are also very interesting. So if somebody wants to try to do that, we can try to put a collaboration on this point. I mean, with the COVID, probably is a little bit more difficult, but anyway, we can also wait.
Then you are inviting collaborations from the university, and
yes, sure.
Yeah, okay.
And this is these are my topic, my current topic of interest, as already said by also Peiman before.
Yeah, we will share these slides on the website,
sure.
and you can see the research progress and other topics.
Sure. And I'll leave you with my email, and you can feel free to contact me. I'm very glad if you contact me, and we can try to find a common ground on some research work or other stuff.
Great. Thank you very much, Alessandro. Great presentation, and I really congratulate you for your braveness and fearlessness, because among professors and researchers on social sciences, you are talking about measuring of something and you put yourself in the fire, I think, because you have very tough questions in here, and I will read some of them. Even our contributors can ask questions directly with raising your hands. You left us 6 minutes, Alessandro. So the first question from Ritis, that very sweating question for you. What will be your recommendation regarding independent variable selection? Is there enough existing literature to address these challenges as the area in is rather new or not? It is a question.
Good questions. Typically, with the social physics approach, you try to study the problem with an empirical approach. So typically, you try to exploit all the sensors, or in case you're not using the social methodology, but for example, the images, you try to exploit all the information you can collect. And then with this, you try to understand which aspects can have an effect on the problem. Just in the first case studies, in that, because we started with a quite strong background on the field, in that case, we had already an idea of the variable that we want to put as independent variable in the problems. Otherwise, it is more an explorative iteration. So you try to understand, we start from a very big book of variables, and you try to understand which one are really interesting for the problem.
Great, excellent. So I don't know if Ritis, are you happy with the answer? Great. The other question is regarding the slide 33, I assume. It is telling that how about other, control variables like patient-related, variables? Were they purposefully omitted or not?
No.
And it is not this slide
yes.
about the hospital and the crying doctors.
Okay.
Why the doctors are crying? This is another question.
No. This is just a picture of. This is just a picture from internet. No, it's not a real one. The other one, the picture of the emergency department, are a real one, but here we didn't took photo because it was real surgery, and also for privacy reasons, etc. It was quite problematic.
So
just to say, once I was also following down due to the surgery.
I see. In this question, they are asking that what would be the best practice for the measuring the patient's factors as well.
Well,
because doctors are happy, it's okay, but
okay. In this case, the patients for the surgery, they were unconscious.
Okay.
Because they were sleeping. So in this case, the patients didn't play a real role.
But sorry, I mean patient's condition, the underlying condition. Old, young, healthy, unhealthy.
You're right.
Obviously, they were sleeping. Yeah.
Okay.
Good.
Okay, it's right. We control it in two ways. One is because we just selected more or less the same diagnosis, because in that surgery that we collected, but also it is the main target of the breast unit, is to solve cancer-related problem with quadrectomy and mastectomy. So with the removal of the cancer from the breast. They are not all the same, but more or less they are quite the same. Anyway, we also control it for the operating team size, because it could be, we can thought that, for example, if there are more team member involved, is more complex and it can have an effect, but we excluded it. And also the surgery duration, that is many times a proxy of the complexity of the surgery. And also if there are some other people in the operating room that observe, for example, the operation. So we considered this aspect in this way. In the emergency department one, we considered the severity code of the patients. Mm-hmm. So also there we control it with the severity code, this kind of
condition-based analysis. Yeah, great. The other, Aidas, are you happy? Okay, great. The other question from Daiva, yeah, would be interesting to learn more about the ethics side of the personal data gathered, as well as data may tell more about people and organizations, is more, you know, transparent in a very transparent way. What side effects are you expecting for the big data of people and the data of management of this data?
Okay.
Yeah.
The first part of, the first part of the question is is simpler to answer. To the second one is very hard. But anyway, okay, with this kind of study, you are a little bit entering in the life of a team and also of individual. But anyway, for example, in these studies, we just asked a voluntary adhesion to the study. It was not compulsory. And anyway, as I said, the social metric badge, for example, but also the application on the smartwatch did not record the content of the speech. So it's impossible to rebuild the content of the speech. And this is important because during the surgery, for example, physicians talk also about the patient conditions, and we can't, record the content about the patient conditions. So it was an important aspect. Mm-hmm. I have also to say that Alex Pentland is involved in the World Economic Forum on the privacy roundtable. So he paid many attentions to these aspects. As regards the data on internet, like Facebook data, email data, well, this is a very big problem. Yes, if they want, they know everything of us. Yes, it's true. And
great. Mm-hmm.
I think we can do nothing.
Yeah. As we just finished our dedicated time. Thank you very much for your help, Alessandro, and thank you very much for all our contributors in here and audiences. We are extremely happy. Just please pay attention to slides number 49 and 50 that Alessandro is requiring your contributions and your attention for those slides. Maybe there are some hidden research questions regarding the collaborating between physical measuring and social sciences and activities there. So if there is no objection against finishing this webinar, thank you very much for your contributions, and see you next week.
And thank you, Peiman.
Thank you. Bye.
Thank you. Bye-bye.
Thank you.